Hello guys, my name is Dylan, my YouTube channel is Director Bros, and welcome to another video. Today we are going to be doing function composition 1. And so topic 1 is review. And so given any function, it has the possibility to be inverted. Not that every function can be inverted, but it may have the ability to be invertible. So a test of invertibility is the horizontal line test. So if what we do is we draw ourselves a graph and we have it go like this, this function is invertible because anywhere that I draw a straight line going through it, it only connects once and only once. An example of one that would not be invertible is this. Because, if I draw a line right here, it touches 1, 2, 3, 4 times. So that would not be invertible. And we can find the inverse by essentially looking at this through a mirror, a 45-degree mirror. So these two are inverse, the inverse, but you cannot inverse this function. And then there is also map. I would like to also review map space, where we can draw our map. This is our map space right here. And so we can put our little maps in here. Inside of that, we have our function space. So where every map has to be a function. Every map can be a function, but every function can be a map. And so these are all the functions in here. And then inside of that we have, for example, a 1-to-1 and onto. And so it just keeps getting smaller and smaller and smaller as it gets more and more detailed. So we can move on to topic 2, which is going to be function comparison. So we have 4 functions, for example. We have f of x equals 2x plus 1. G of x equals 3x minus 1. H of x equals x plus 1 over x minus 1. And then m of x equals to x minus 1 over 2. So these are our 4 functions. And so the big idea here is if we draw our 3 maps, right here, so we go 1, 2, 3. The big idea is if we have 1, 2, 3, 4. 1, 2, 3, 4, 5. And 1, 2, 10, 11. That basically 2 goes to 5. And 5 and 2 and 5 go to 10. So one input is another output. Every output could be an input for something else. Every input can be an output for something else. So what we're going to do here is we're going to compare the functions. So we're going to have f of g of 2. And so what we're going to do is we're going to compare these two functions. So this equals f of, and then g of 2. And so what we can do is, so g of x equals 3x minus 1. So what we can do is we can replace g with 3x minus 1 and replace 2 with x. Replace x with 2. So what we're going to do is it's going to say equals f of 3, replace x with 2, 3, 2, minus 1. And so this equals f, let's see, 6 minus 1 equals 5. But look, we have another case where it's f now, and then in parentheses 5, so we can replace x with 5 now for f. So we're going to say this equals 2, 5 plus 1, and that 10 plus 1 equals 11. And so these are some simple versions. And let's do one more just so we can show more understanding of the topic. So here let's say f of g and of 1. So this equals f and then g of 2, and so this, 1, sorry. And then this is going to equal to f of 3, 1, minus 1, because we're replacing x up here with 1, and so that is going to equal f of 2, because it's 3 minus 1 equals 2. And then we can finally say 2 plus 1, which equals 5. And so these are simple versions. So we can move on to topic 3, which is going to be our final topic of more complex or more advanced versions, I must say. So we're gonna now use m. So we're gonna say f of m, or 2. And so this equals f of m of 2. And so if you remember, m was x minus 1 over 2, so this is going to be equal to f of 2 minus 1 over 2. So what we're going to do is we're going to now say that 2 minus 1 equals 1. And so 1 doesn't divide in, or 1 only goes into 2, like, 2 doesn't go into 1, but, so it's 1/2, because it's 1/2 remaining. And so what we're going to do is we're going to go, this equals f of 1/2 and so this is 2 of 1/2 plus 1, and so let's see, 2 times 1/2, so there's 2 1/2, which equals 1, plus 1 equals 2. And so this is inversible because our starting function up here is the same down here, and so we inverse them. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.